Today's lesson is implicit differentiation. Now, we stole these notes from somebody we found. We like his layout and format. The words at the top are a little confusing, okay? So the goal is when I have a function and I take the derivative, okay, the derivative of x is the same as dy dx. I'm taking the derivative of a function, y is equal to something in terms of x. Maybe it's 3x squared plus 4x, all right? And you differentiate, you apply the rules. You end up with 6x dx dx, which is 1, plus 4. This is defined explicitly in terms of x. This example right here is an explicit function. Y is defined in terms of x. This one is implicit. That we didn't solve for y first. And our goal today is to find the derivative of this function without solving for y. I don't know how to solve that one for y. I could move the x squared over and factor out a y, but I'd still have a mess and I wouldn't know how to solve it. Also correct this typo here. It can't be written. It wants to be solved implicitly. This didn't make any sense at all. All right? This statement I stole right out of the book. I want you to copy it and write it down. So stop the tape and write it. It says, when you differentiate terms involving y, you must apply the chain rule because you are assuming the y is defined implicitly as a differentiable function of x. Okay, so let's do some examples and see if it helps make sense. There's a lot of words there that don't matter. All right, so they want me to find dy dx. I don't want to solve for y first. So if you differentiate x squared in terms of x, you get 2x. If you differentiate this, you get 2y, and then you have to differentiate y with respect to x, because we're assuming this is a function implicitly defined, okay, in terms of x. The derivative of constant is still 0. And now your goal is to solve for dy dx. So you subtract your 2x from both sides. And then you divide by 2y. So you get negative x over y. That's the derivative. Okay, your derivative is defined in terms of x and y. Do it again. See, we don't have to solve the equation for y. We're going to differentiate implicitly. This is only has x's in it, so it's 6x squared. This is 4y dy dx plus 0. Solve for dy dx, you divide by 4y, and that becomes 3x squared over 2y equals dy dx. It's the derivative of that function in terms of x. It happens to have a y in it. All right? Do it again. You end up with 9y squared dy dx plus 2y dy dx minus 2 dy dx plus 8x equals 0. Now, you want to move the terms that don't have a dy dx to the other side and factor dy dx out of all the other ones. So I'm left with 9y squared plus 2y minus 2 equals negative 8. And then you divide. So dy dx becomes negative 8x over 9y squared plus 2y minus 2. Say we had to write an equation for a tangent line. You'd get a point. They'd give you an x value. You can solve for y. You can solve for the y, you plug the x and y in here and get your derivative. It gives you the slope. Okay? Your turn. Do this one. 3y squared dy dx plus 2y dy dx minus 5 minus 2x equals 0. Pull your dy dx out and move your 2x to the other side. Now divide. And that's your answer. Not bad. Okay? The thing to remember is y is a function implicitly defined in terms of x. So you've got to take the derivative of it. Okay. You got to do the product rule. First times the derivative of the second plus the second times the derivative of the first, derivative of y, the derivative of x. Okay, take the terms that don't have a dy dx in them over here, so you get 1 minus y cubed 3x squared, and I'm left with x cubed 3y squared dy dx minus dy dx. So factor that out, and you're left with x cubed 3y squared minus 1. Now you divide, so dy dx is equal to 1 minus y cubed 3x squared over x cubed 3y squared minus 1. Okay, chain rule. First, derivative of the second plus the second, derivative of the first, do your chain rule, take your terms that don't have a dy dx in them over to the other side, dy dx equals 5 plus sine x sine y divided by cosine x cosine y. Ugh. That one I'm going to let you do on your own. You can go check the answer. This one, it's multiple choice, so let's see what we can do. You get 10x minus, you got to do the product rule, 2x dy dx plus y times 2. I put these guys as a term. It doesn't really matter. Okay. Plus 14y dy dx equals 0. Let's see, 10x minus 2x dy dx minus 2y plus 14y dy dx equals 0. Move the terms that don't have a y in them, so dy dx. Negative 10x plus 2y. And then I'm going to factor out the dy dx. And I get negative 10x plus 2y over negative 2x plus 14y. And it doesn't look like any of my answers, so what do I have to do? Let's see, factor out a 2. And it looks like it changed the order, so I have y minus 5x over 7y minus x. Bingo. This is what I mean by do I have to simplify it? Well, if it's a multiple choice question, yep, you got to be able to match the answers. Okay, that's day 1 of, or part 1 of implicit differentiation.